Hello, everybody. Um, my name is Dmitry Dygalo, and I am a tech lead at Kiwi.com. I live in Prague, Czech Republic. Initially, I was graduated as an information security specialist, and I do Python from 2011. And I maintain a couple of open source libraries, for example, like Django Money. Okay, so today I'm gonna talk about testing network interactions and a little disclaimer that it's only about mocking network. So no real network interactions for now. I will show you some code, some project example, and then we'll show you some different approaches on network testing and show a couple of real examples how it helped me in my daily job. Okay, so let's imagine that a couple of years ago we started with a really nice application for flights booking. It was super cool, and after a few years it became super big and hard to maintain. So we decided to go kind of a usual way. We decided to split it in microservices, and it can't go without this image, right? Nowadays. So we started looking for a good candidate for cutting out, and we found it. It was exchange rate, for example. It's kind of isolated thing. It's not connected really tightly to anything else. And we could imagine our new approach like this. So we will have our booking application, and it will call these exchange rates. So it will interact over network. Seems nice, but let's proceed with the code that we have so far. We have Python 3.7. We use Flask and Connection. Connection is a tool for working with open API schemas. SQL Alchemy, PostgreSQL, and PyTest. So our modules are super simple, and we have transaction, for example. We store amount in currency and amount in euros, and we have exchange rates, 2 euros. And we have our payments module that before saving a transaction, it converts its amount to euros and uses this exchange module. And then we just commit the data. So our exchange code could look like this. We are just looking into the database, we're fetching this rate and doing some computations. And our tests could look like this. If we have this particular rate, we are checking if it's converted correctly. If it's not, then it should raise an error. So let's cut out this beautiful application. So first of all, let's try to write the code that will call this external API. Synchronous version could look like this. So we will use requests, and just for a while it will run on our local host. And then we have a little bit of error handling, and we just returning the result to the user that called this function. Okay, so let's pretend that this new code does not exist just for a while. So our ad hoc test could look like this. We are just using regular unit test mock module with together with PyTest mock plugin. So we are just replacing the output of the function to something that is static, just to have other code tested. And for error, it could look like this. So we use side effect. We could refactor it into something more configurable. We could extract it into a separate fixture, have some inner function that will be called in tests like this. So we have more reusable code. Or it could be even something like this with auto use feature from PyTest. We'll just wrap our test into setup race marker, and we'll do this setup outside of the test scope of the test code. It's basically the same stuff. It's called dynamically, so it's the fixture is loaded on demand and used outside of the test function. Okay, nowadays asynchronous code is kind of a popular way to achieve some performance issues with to overcome some performance issues in on I/O level. So we could use AIOHTTP. The code is really similar to request, except for the fact that we use coroutine for it, and the logic is almost the same. So our other code should be adapted as well in some way. So we just rewrite our save transaction function into a coroutine. We use await, and we pretend that the rest of the code for saving transaction is working asynchronously as well. So to utilize the same approach with ad hoc test, we could use PyTest ASYNC plugin, and we need to wrap all our tests into we should apply PyTest mark ASYNC and write our tests as a coroutines. So it's really similar to synchronous one, except for the fact that we need to replace this function with some coroutine. And the rest is the same, and we need to utilize await syntax for our new coroutines. And okay, for exception, it could work like this. Okay, so basically this approach is really easy to set up. You just mock everything and set up how it works and just run the stuff. And it's kind of flexible because you could utilize the features that are available in standard library. But these things could become really messy really fast. Yes, you could just replace everything with mocking and run your test, but your level of confidence with your code, I wouldn't say that it will be high. Usually you can afford this because you need to actually test your code, your API wrapper for that case. So let's move on. And for requests, there is a nice library called Responses developed by Center team, and there is a PyTest plugin for it. So it provides an API where you could just add some mock for your request, and it will be matched when the actual interaction will happen. And you could just emulate some network exceptions like connection issues, everything basically. It works really, really nice with requests. And it provides you with an ability to specify some dynamic callbacks and specify dynamic responses. So you could just write this dynamic logic on your application side and run it as a callback for requests that will be intercepted, and then just use it in your PyTest marks. Okay, so basically responses are really, really well supported by the Center team, and it has a lot of nice features that covers a lot in for requests. But it's requests only, so no asynchronous stuff, nothing like that. So there is an universal solution called POOK, and basically it provides really similar API but it has no PyTest plugin, so I wrapped it a little bit to have nice fixture in our tests. So you could just add these response marks to this fixture. It's really similar to responses. It has a little bit different syntax, but it works really in a very similar way. And the cool thing is that it works. It provides the same API for synchronous code and for asynchronous as well. So you don't have to use something else. So you could use both. Use both asynchronous and synchronous code with the same mocking library. So the only difference is that you have to specify your tests as a coroutines. And the rest is the same. So it has a lot of features, like you could match your headers or body with some regexps, or you could emulate some response delays even. You could specify callbacks, and many more features are available there. So it works with a lot of different HTTP clients, like standard library, ORL, lib, HTTP client, AIOHTTP. It works fine with requests, ORL, lib3, but unfortunately it does not support the recent AIOHTTP version. Okay, so all these libraries that provide some generic API, it's usually really convenient to use, and it allows you to record multiple requests and responses. So you could test some sequence of requests, but sometimes it's kind of tedious to specify everything by hand, all responses, all statuses, and all the things. So it would be nice to have something that does not require this tedious configuration process. And actually, there is an approach for it called CASSETTES. It came originally from Ruby, and there is a port of Ruby to Python called PiterPy, and there is a plugin for PyTest. So basically, what you need to do is just mark your test with PCR mark, and then just run your usual test. That's it. But actually, here we don't have any responses, so let's write actual microservice. So let's imagine that it's simple Flask application with static rates, and it converts incoming value in currency to euro if exchange rate is available, and some small error handling logic. So after we run the test, a cassette will be recorded, and it will be called in the same way as the test is called, in cassettes directory near to test you're launching. So it consists of different interactions that we're recording during the test run. So it has request and response with headers, body, and all the stuff. And then you could just run the test and all the interactions will be replayed. It has different record modes, so you could, for example, record all interactions and never replay them, so they will be rewritten. Or you could record it if there is no cassette and replay it otherwise. For new episodes, it will record it if there is no cassette and will not record anything else, basically. It will replay and record only new episodes. And you could just disable all network interactions with non-record mode. Nothing will be recorded ever, and it will always be replayed. And if there is no match, an error will be raised. Okay, it provides a lot of different utilities. You could filter out your secrets from requests, so you could just filter your authentication, for example, from headers, query string, post data, or you could specify something that you need by yourselves. So it's really easy to use. It does not require any complex configuration. You could just wrap it in VCR mark and run your test, so it will be recorded. and it supports a lot of different HTTP clients as well as synchronous and asynchronous AIOHTTP requests, standard library, everything. So you could record as many interactions as you want, but there is no exception emulation basically. So you could not do this. So CASSETTES does not provide it, but generic LIBS does. They do. So the best way is to combine this approach together. So when you can't emulate something, use generic libraries. If you need just to replace something, you could use these cassettes. Okay, so let's go for real-life examples. First one is about API integration. So a couple of months ago, I started to integrate MasterCard API. I started in TDD style and just create a fixture with this imaginary client class, and I wrote a test like this. So I imagined that this MasterCard instance will have a method that will asynchronously create a payment card for me. Just as an example. I wrapped it in a VCR mark and ran the code. It failed. Then I wrote a little bit of network code. I created some XML payload, added some parsing, and I was running it. I was iterating over it, and eventually I got what I wanted. So I got this HTTP client for this MasterCard API. So the process is like this. You write a test with all VCR record mode. You're adding some code. You run your test with sandbox credentials, for example. You adapt your code and test until it works. Then you make your assertion stronger. You're adding more functionality. You fix some things that appear on the way, and then you're just iterating over it. Another cool example is about refactoring. Some tightly coupled code. We had a class like this, 2,000 lines of code with multiple external API calls. It was tightly coupled. Everything depends on the instance state, and there were no tests at all. So it looked like this. Basically, there were dozens of different attributes, including mutable ones, and there were some load data got method that just made everything. So it was there were some calls to external APIs, database queries, and everything was stored in instance attributes. So I wrote a test, and then I ran this method. So there were a couple of network interactions. I recorded it, and then I asserted the instance state. So actually, I recorded something that really happens. It's real data. There are no like harmful actions in this part of the code. So the next step basically was internal refactoring, and the process overall looked like this. You're just choosing some part of the code that you could safely run on production or sandbox or environment like this. You record all network interactions for different cases, as many as you need. The more the better, basically. You add more detailed assertions about your instance state. Then you refactor your code and add tests for new refactored code. Then you repeat until you're happy with the new code, and then you are going to some upper abstraction levels and do the same. And the class looked like this in the end. So, by the way, who is using Athers? Who know what is that? Well, yeah. So in the end, it looked like this. We have like only static attributes that we really need. We have the same interface that we had before, but inside, everything was working with separate functions that are tested and that produce the same effects as the old code. We are storing only needed in the instance attributes, and most of the new code is stateless. So we have the same high-level interface as before. We have much better internal structure, and we actually have some tests. So it's an intermediate state when you have already some confidence in your code and you could go further with the refactoring. So you have some confidence to be the starting point at least. So these approaches could be used in various situations, like a splitting monolithic application, or you could use it for TDD style API integration. You could fake responses of external APIs, and you could refactor some tightly coupled code. We used unit test mock library with a couple of PyTest plugins for our ad hoc tests. We used responses. We used PUC for a generic case, and we used PiterPy and accompanied PyTest plugin for CASSETTES. There are some examples in this repo, and basically that's all I got. Thank you very much, guys.
Thank you. Let's have QA session, and Alimov again. All right.
Thank you, Dmitry. I have a question. Have you tried some kind of property-based testing like fuzzing and hypothesis?
Yes. Basically, hypothesis. I use it from time to time to discover some weird edge cases for the code that I'm working on. But at least for now, we don't include it in our CI process. But we use it as a discovery step, I would say. So okay. And then we write some tests for these edge cases.
Okay.
Hi, thanks for talk. So what you mainly described is how you do a unit testing, right? So in that way you can do a proper mocking of with the cassettes of external services. But imagine if you have integration testing of all your microservice infrastructure, and within it you need to also have an external interaction in some of your microservice. How would you test that?
Okay, I would say that there are two things. First one, you could mock it in some way on your application level, but it's one level of confidence. And this talk is mainly about this. So it's only about mocking. So it's part one. And there is an approach where you could actually test multiple microservices, for example. It's a real network. So it's kind of a topic for a future talk, but for example, you could try PyTest Docker. It's a library that utilizes Docker Compose. So you could run multiple microservices as a PyTest fixtures. So you could somehow set up them, run your integration tests. Also, you could apply some mocking, but you could like emulate an external service with some mocked one, which will work on this external address. So you will route all the traffic to it and all this stuff, but it requires like more sophisticated configuration, I would say. So you will run all these things, you will run your integration tests, and then you could assert microservices states basically in some way. If for example, if you have an access to its DB, you could just check what is in the DB after test ended. So something like this, but it's more like bigger topic, I would say, to discuss.
Okay, thank you.
I would like to ask one question, if that's okay. I have maybe you've even touched that topic in your talk, but just to be sure, what is your opinion on current state of AIOHTTP and its performance, stable conditions, stuff like that? Because last time I personally checked, it was far away from the thing I would like to use in my production code. So what is your opinion?
From my experience, I would say that I changed my mind, and it's like when you're, for me personally, it worked like you're thinking. I was thinking sequentially in some synchronous APIs like request has. So I was quite annoyed the amount of this async await stuff. I didn't got this at the moment when I just started using it, but over time, for me, it became better. Maybe from one point is that maybe I just accustomed to it, I used to it, and I know that there are some adjustments in the API. For example, I think context managers were introduced quite recently, so yeah, it eventually will be much better. So from my point of view, and that performance stuff, it's quite nice if you are doing it in the right way. For example, you could write asynchronous code that is still blocking, so it will not help you. So you have to know what are you doing exactly, and if you're doing everything right and you basically know how it will work, it could work really great, I would say, from my point of view at least.
Okay, I guess that's answer my questions. So I guess we will. Thank you for your talk and for your answers.
Welcome. There was one question, I believe.
No, I think
okay.
About timing, we will move our discussion to the break. And just before we are heading to the break, I will like to invite back to the scene Stan Lee, yeah, our first speaker. And I have a little bit of something I would like to give you all for your talks. This is the official mascot of this venue. It's T-Rex, mascot of Selectel. So nice to have you there, guys. And we are heading to the coffee break, to the beer and stuff like that. Yeah.